All right, everybody, here's another video, this one on the law of cosines. So the law of cosines is the law that actually gives us the Pythagorean theorem. You'll notice this a squared plus b squared, or a squared equals b squared plus c squared, or maybe you're more used to seeing it as c squared equals a squared plus b squared, is in the law of cosines. And then the other part corrects for what happens when you don't have a 90-degree angle. Now, the cosine of 90 degrees is 0. So if you're doing the Pythagorean theorem, then what's really happened is this part has gone away. Okay? We'll see that a little bit more as we go along. If you want to use this instead of SOHCAHTOA, by all means. Or instead of the Pythagorean theorem, perhaps. All right, when you're using the law of cosines, you're not going to have a matching angle or side. So you'll either have side, angle, side, or side, side, side as the information given to you. But it won't be where you know capital A and lowercase a, the angle A and the side A. That will not be the case. Okay, when you start a problem, you have to decide which law of cosines you're going to use. Sometimes there's more than one option. Sometimes there's only one option. So in this one, I see that I have 8, 14, and 19. We're going to choose to use the one that emphasizes the largest side. So we're going to choose this one because our largest side is B. Now, it's not that using the other ones would give you the wrong answer. The issue is that when you do your next step, you might have to fend off an extraneous solution, and you can avoid that. It is possible. Okay, so here we go. First, we decide what formula we're going to use. We said the b squared one. Then we go ahead and we fill in all the given information. So what I'm going to be finding for this is actually this largest angle. Okay, that's what I'm going to be finding first. Looks like it might be 90 degrees, but you never know. All right, so I'm going to start by getting rid of all the constant terms. I can't get rid of the 224 in this step because it's not connected to the rest by addition and subtraction. It's most closely connected to the cosine of b by multiplication. So this multiplication right here is more powerful than the subtraction. So we can't just add 224 to both sides. Okay, so when we do that, we're going to get 101 equals negative 224 times the cosine of b. And we're going to divide the cosine of b by itself. That's going to allow us to use our arc cosine to get that b is 116.8 degrees. All of that just comes straight out of your calculator. You have to remember that you're using the arc cosine. You have to remember that you're in degrees. But other than that, pretty simple. Okay, now once you do that, you're going to need to find angle A and angle C. And you're going to have to do that using the law of sines. I always find the smaller side first, just out of habit. So I set that up, or I'm sorry, the smaller angle. So I set that up to find A, just like we did in the last couple law of sines videos. Here, what I'm isolating is the sine of A. So I'm going to need to do an arc sine on this one. I can get this answer straight out of the calculator. It's going to tell me that A is 22.1 degrees. You'll notice that I just plugged this whole thing into the calculator, and that's because that keeps me from rounding. I might end up rounding a little bit in my problem, but I can round a lot less by trying to carry things through as the exact values. And actually, when I typed this into my calculator, I didn't use 116.8 for my degrees. I actually used the entire answer that I got out of here. kind of using the last answer function on the calculator. Okay, since I know that A is 22.1 degrees, I can subtract from 180 to get that C is 41.1. All right, next problem. Whoops, don't look at that. All right, so I'm given enough information to draw a triangle. Now my triangle's not great, admittedly. I'm not the world's best triangulist, but I've done my best here. Okay. I set it up so I have an acute angle, and when I drew my triangle, I just looked at which angle was bigger, and I thought to myself, C looks a little bigger, so I'll put 36 opposite that angle, and I'll label this one C. This one looks a little bit smaller, so I'll call that A and put the 32 across from it. Now, what I don't know here is B. When I'm given an angle, all I'm going to be able to do is to find B by plugging in the angle. So by coincidence, I am using that same formula as last time with the B squared equals. That allows me to find B squared, which allows me to find B. Okay? Now, I went through and I used the law of sines and cosines to, the law of sines to find A and C, and I'd like for you to do that now. Okay, pause the video, and the answers are coming up in just a second. All right, there they are. A is 54.8, and the C is 113.2. What I think is interesting here is although sides A and C are quite close, their angles are not close. And that's kind of an interesting thing about the proportions between the sides in the triangle. All right, hope you enjoyed that. We'll move on to another video in just a second.